Hello, good afternoon. I would like to welcome you all to our webinar, Big Data and Evaluation. This webinar is part of GEOPI 2021 webinar series. GEOPI is the Laboratory of Studies on the Organization of Research and Innovation from the University of Campinas, Unicamp. GEOPI was founded in 1995. We have 25 years. And we have faculties, researchers, and students from the Department of Science and Technology Policy, the School of Applied Science, and the Center for Studies of Public Policies, all from Unicamp, as well as researchers from other organizations in Brazil and abroad. This webinar is also part of Global Evaluation Week, that is an initiative that congregates lots of events taking place all around the world to promote knowledge sharing and networking in the evaluation field. Our idea today here in this webinar is to discuss how big data and machine learning are being used and how they can be used in outcome and impact evaluation and also in STI evaluation. Our special guests today are Professor Michael Bamberger and Professor Rodrigo Costas. We are very, very pleased that you accepted our invitation to join the seminar. Professor Bamberger is an independent consultant. He holds a Ph.D. from the London School of Economics and has more than 40 years of experience working on development evaluation around the world. Professor Rodrigo Costas holds a PhD in Library and Information Science from the Spanish National Research Council, and he is currently a senior researcher at the Center for Science and Technology Studies, CWTS, at Leiden University. And his areas of expertise includes the field of information science, Centrometrics, and social media metrics. Finally, I would like to introduce myself. I'm Adriana Bin. I'm assistant professor at the School of Applied Science, Unicamp, and one of the coordinators of GEOPI. We have also here with us Professor Sérgio Salles and Professor Ana Maria Carneiro. They are all coordinators of GEOPI with me, and also we have Vini in the support here today. My role here today is to mediate the debate. So we are going to begin with Professor Michael Bamberger, and then we go to Professor Costas. Each of you will have 30 minutes to present, and after that, we are going to bring questions from our audience in YouTube. So I kindly ask for you in YouTube to put your comments and questions during the presentation. Then we have people that are going to get the questions in the chat and bring here to our Zoom meeting. And please feel free to write in Portuguese if you like, then we can translate to ask both speakers here. So thank you, everyone. We know that we have a lot of people from different parts of the world today. So it's a great pleasure to have you all here. So please, Professor Bamberger, you can begin. The floor is yours.
Hello, everybody. It's a pleasure to meet with people from so many different parts of the world. And bom dia para a colegas do Brasil. I'm going to be giving a brief overview, an introduction to the potential opportunities for incorporating big data into evaluation. And I'll be talking a little bit about how the progress which has already been made in incorporating big data into development programs. And I'm going to talk a little bit about the opportunities for incorporating complexity into development evaluation now that we have the tools of big data, which makes it possible to analyze larger volumes of data than was previously possible. So welcome everybody, and I look forward to the discussion and questions with you at the end of the session. So This is the plan which I have to give an overview of big data and give examples of how it's already being applied in development evaluation, and think about some of the opportunities and challenges for the future. So I'm going to begin with a brief introduction to big data. And I'd like to start by reminding us of some of the challenges which current evaluation methods face, which is essentially why it's so important to have access to all of the resources of big data. So firstly, it's very expensive and time-consuming to collect data for evaluation. So many evaluations have to work with relatively small samples, which limits the kind of analysis which can be done. It's also difficult to cover long periods of time before the evaluation begins and after it ends, because of the cost and the complexity of collecting the data. And there are many useful kinds of data we would like to use, but which it's very difficult to collect, for example, on behavior, process changes, attitudes. So there's a number of constraints of the kinds of data we can use. Also, most evaluations are retrospective. They're conducted towards the end of a program, and they do a post-mortem of how the program evolved. But they don't provide guidance to an ongoing program, because most of the evaluations don't come out until the program's ended. So this is a major limitation, which we'll see how big data can help to address that. And then the challenge of emergence, that programs change constantly as they're being implemented, but many evaluation methodologies start with the baseline, and you assume that you're measuring the same program 5 years later as it was at the beginning of the 5-year period. So this is a serious issue if the program has dramatically changed in its coverage or the populations which are being addressed. And then finally, we'll be coming back to talk about the challenges of capturing the complex environment in which most programs are operating. We'll see that's a big problem for evaluations at the moment. So a few of the benefits which big data can potentially offer, which we'll be coming back to discuss in more detail. Firstly, you get a fast and economical access to data. You can have much larger samples, and you can sometimes even cover the complete population if you need to. Importantly, machine learning now makes it possible to automate a lot of the routine data collection and analysis tasks, so that the evaluators can actually focus on planning the evaluation rather than just worrying about have all of the questionnaires been returned and have they been analyzed. You also have access to a much wider range of kinds of data with much broader geographical coverage and longer time periods. And as Rodrigo will be going into more detail, the new world of data analytics and artificial intelligence offers a vast new range of ways that the data can be analyzed. So briefly, just a few of the kinds of big data which are being currently used. Social media analysis, Facebook, Twitter, WhatsApp, all of the other kinds of social media is a very powerful tool for looking at opinions, social networks, analysis of hate speech and fake news, among other things. Satellites and drones is probably the most widespread kind of big data at the moment for evaluation. You can track mobility, look at longitudinal trends. Radio calling programs are very important in rural areas where a lot of people don't have access to internet. These can be used for analyzing conflicts within communities, particularly where you have a big refugee population, or for identifying the concerns of the community. Mobile phones are used widely for assessing the effectiveness of programs within a community. Do people respond to messages to go to the health center, for example? Also for identifying poverty hotspots. Poor people tend to buy airtime for their phone every day or every week. And when their income goes down, they buy less airtime. And when it goes up, they buy more. So this is a very good short-term indicator of changes in poverty. Administrative records, it's now becoming possible to integrate data from many different organizations and to look at patterns and trends in the PDF files, which organizations are sitting there but haven't been able to use. The Internet of Things, smartphones, other devices, you can remote sensors, you can monitor water, power usage, and a number of look at people's mobility. So this is an exciting new very new development. Phone companies keep records of all of the calls which are made from whom and to whom. They don't have the content of the call, but you can track who was calling who. This is a very useful tool for example, for looking at mobility or for assessing integration. Sorry, that jumping around a little bit. Okay, so to conclude the first part, defining big data. It's huge volume, generated very fast. It's too large to analyze on a single computer. It's almost always on, whereas if you do a evaluation survey, you only have data at one point of time, but things like Twitter, the information is updated every second. Satellites, you get maybe it's updated once or twice a day, depending on the frequency of the images being taken. You also have longitudinal data sets which cover much longer periods of time. The data is also non-reactive. If you conduct a survey and you ask somebody how much income they've got, the answer will depend upon what they perceive as being the purpose of the survey. Whereas with big data, the information is already being collected. So the fact that you're using it, it's non-reactive, which is an important consideration. And finally, big data can capture a much wider range of kinds of data. So this is a brief definition of the characteristics of big data. So now briefly, some examples of how big data is already being used in development evaluation, and we can come back in more detail when we get to the question time. It's being used very widely in refugee programs for mapping settlement growth, population movements, infrastructure, disasters. You can analyze social conflicts, hate speech, fake news. You can predict the growth of vulnerable populations and the demand for services, predict what is going to be the future growth of the refugee population and what kind of services will they need. You can assess the integration of different populations into a host country. Infodemiology is now being used by organizations like the World Health Organization to track the spread of information on things like COVID, to see how much false news and to see how you can improve the dissemination of information. This is something which Rodrigo might possibly be mentioning. Then the integration of data sources from different agencies, including text analytics. So you can begin to bring together data from many different organizations, which is important if you're working on a health program, for example. There's lots of different organizations have the data that you would like to use. So these are ongoing applications in the development world. And just briefly, some of the applications of the data analytics, machine learning and artificial intelligence. Just 4 examples. The first is creating natural experiments. It's very difficult to use randomized control trials in development, but very often you can look at all of your population and you can match your target population with comparison groups by using satellite images and these other techniques. And you can then use things like propensity score matching, so you can get a very good match for your target population. This is a very, very powerful tool, the creating natural experiments. We've already mentioned creating integrated data platforms. Seems very boring, but just the fact of being able to draw together many sources of information from different agencies is just a very powerful way of getting a much more broader vision of the programs you're looking at. Text analytics, finding patterns and trends in large volumes of PDF files. Many organizations have had all of this data sitting there for years, literally millions of pages of text. They haven't known what to do with it, but now it's possible with text analytics to go and scan large data sets and look for patterns. And then very importantly, predictive analytics. You can begin to predict how programs are likely to evolve in the future. And you can create, again, natural experiments. You're recommending certain changes, and you can compare groups who receive these changes and groups which don't. This is really critical for the use of big data, that you can, evaluation can become a dynamic management tool where you can actually be changing programs as they're evolving rather than just looking back historically. Just a few examples we've already talked about from social media analytics. I just put these on the slide because Rodrigo may possibly be touching on some of these in a slightly different way, because this is one of his fields of expertise. I'm going quite quickly to cover as much ground as we can in the half hour, and we can come back in the question time. So the third point I'd like to talk about is the potential for studying complex environments in which programs operate, which big data begins to make possible. All agencies say that their programs are complex, that they work in complex environments, but if you look at most evaluations, it's a simple evaluation with a pre-test, post-test comparison of the specific target population. And so very few evaluations are actually focusing on complexity, even though everybody says it's very, very important. So this is an exciting potential area for big data. So just to understand what we mean by complexity, this is a map of the SDGs. The large circles are each of the SDGs: education, health, environment, transport, etc. The small circles are the sub goals of the SDGs. And you can see from this that any SDG you are looking at wanting to evaluate education programs or health programs, they're intimately linked with all of the other SDGs. So you really can't say much about the effectiveness of a health program without understanding how it's being supported or made more complex, more challenging because of the linkages with other SDGs. So this is just a very quick image of what complexity looks like in the real world. So a simple map just to help us identify what are the areas of complexity we'd like to look at. The blue circle, the blue square is the intervention, which itself can be simple or complex, but many interventions may be relatively simple on their own. But then when we jump to the right, a big program may have up to 100 individuals and institutions involved. The financial agencies, policymakers, central government agencies, regional offices, civil society, consultants, the private sector, academics, public opinion, all of these interact and significantly influence how a program is operating. And so you can have a program which on its own would be fairly simple to implement, but it gets seriously affected by the interactions among all of the stakeholders who are coordinating with each other, competing. Sometimes they have different goals, different reporting mechanisms. So most evaluations don't really address this in a systematic way, but it's really critical for understanding the factors affecting outcomes of a program. Then at the top, the system within which the program operates, all of the economic, socio-cultural, political, environmental factors affecting how a program is implemented. And then at the bottom, actually thinking about the processes of change. Are they simple or are they complex? So we really, for an evaluation, would like to be able to look at all of these different dimensions, but most evaluations until now have really not done this because of the difficulties of getting access to the data and for analyzing the data if you can collect it. So big data begins to open up opportunities for us. So this is the point that most current evaluations are not addressing complexity, even though they would like to or should be. So just a few of the tools that big data offers for conducting complexity responsive evaluations. It's now possible to collect the large amounts of data which you need for looking at complexity, all of the external factors, the economic, political factors. You can now begin to collect data on these and model them. You begin to get data in real time, so you can look at processes of change by getting constant feedback from many of the sources of big data, rather than only getting 6 monthly reports, perhaps from a monitoring system. So it becomes possible to study ongoing processes, which are really critical for understanding how programs are actually implemented. It's not just looking at the outputs, it's understanding what goes on during the 3 to 5 years of implementation. So one of the exciting possibilities which people are just beginning to look at is the use of systems analysis, systems mapping, systems dynamics, social network analysis, for example, looking at the linkages between the different organizations, agent-based modeling, where you assume the goals of particular actors in a program and you model how different goals will affect outcomes. So systems analysis is a tremendously powerful potential tool for looking at complexity. and evaluators are just beginning to think about how they can do these. Previously, you couldn't because you didn't have access to the large amounts of data which you needed. Now, this data is beginning to become available. So this is a very exciting development for evaluation and for bringing in all of these systems modeling colleagues to work with evaluators. So that's just a little bit of one of the most exciting, I think, potential areas of big data is for being able to look at complexity, model the system as it is actually operating. So now just a few of the challenges of using big data. Tremendous opportunities, but there's also challenges to keep in mind. Firstly, bias. Most big data sources only cover certain groups. For example, if you're analyzing Twitter data, by definition, it only covers people who use Twitter. And so many of the sources you're using exclude large sectors of the population, and you may not be completely clear what kind of bias is there. A weakness of much of data analytics is it's data-driven rather than problem-driven. People look at what kind of data is available and they start thinking, what kind of analysis could we do with this, rather than the evaluation approach of saying, what is the problem? What information do we need? Where can we get it from? So this is an issue which evaluators and big data scientists are going to have to negotiate. Then a lot of people say that big data is objective, but in fact, it reflects the social biases of the society in which it's collected, racial biases, economic, gender biases, and we can go into some of the evidence from the COVID of what kind of data is being collected. We know much less about racial differences in access to vaccines than we know about how middle-class white people have access to vaccines. We don't know about the gender differences in the impacts of COVID so much. So racial biases are really built in. Then there are dangers of reliance on automated decision-making algorithms. Universities nowadays, many of them use an algorithm for selecting candidates to accept in the university. Banks use automated algorithms for selecting people who are eligible for loans, for mortgages. Police departments use algorithms to identify what are the areas where what they consider high crime and which they're going to be focusing on. So one of the things with these algorithms, they're tremendously powerful, but many of them are proprietary. They're owned by a private company which refuses to give information on what were the indicators which were built into the algorithm. So you don't actually know how the decision was made. If we have time in the questions, I will mention an example in Cincinnati in the United States, where it's estimated that 500,000 people were eliminated from the welfare rolls because of an error in the algorithm which was being used by the state government to prioritize who was eligible for welfare payments. 500,000 people were initially eliminated because of an error in the algorithm. So this is algorithms tremendously important, very valuable, but some issues. Then there's a lot of methodological challenges we can discuss in more detail if you're interested. Problems of data quality, a lot of big data, social media data, for example, it's very difficult to know what it actually means, how to interpret it. Many data scientists don't believe in causality. They say that if you have a large sample, a correlation is sufficient for what you need, whereas evaluators insist you need theories of change, causal models. This is an ongoing debate. The lack of a theoretical framework, again, evaluators believe you can't start knowing what data to collect until you have a framework, theoretical framework. Data scientists say, collect all of the data that you can find and artificial intelligence will sort it out for you. So there's a big debate there. Then ground truthing, which is validating the data you're collecting to know how accurate or reliable. Most of the satellite images are not ground truth. You look at the satellite image and an expert sitting on the other side of the world will interpret what this tells you about the growth of poverty, the spread of disease, flooding, and it's normally not checked on the ground to see how valid this is. So this is a big issue, what evaluators would call triangulation. So these are a few of the challenges of big data, and we really need to keep in mind the issues of data security and privacy. it's quite difficult technically and organizationally to set up a really good system for protecting your data. And so if you're working on humanitarian programs, people can get killed if data leaks. So it's not just an academic discussion. And particularly difficult when you have many different organizations sharing data to have a good data security system. It's really difficult to think about informed consent when you're using remote data. And then the question of the digital divide, who has access to the new information technology and who doesn't, including big organizations can use data analytics for evaluating large programs. A small NGO may not have access to the big data. Then a really serious issue, the exclusion of vulnerable groups from decision-making. If you're using remote data analysis sitting in your office in Campinas or in Washington, you may just not be aware that there are many vulnerable sectors in the communities you're looking at you don't even know that exist. You have to actually be on the ground to find out who is benefiting from programs, who is being excluded. And most big data doesn't do that. And one of the concerning factors, you talk to many agencies and they say, big data, remote data collection is great. It's so much cheaper and so much quicker. And I've heard many people say, you don't have to waste time going out to visit the community because you know what they want sitting in your office and analyzing social media. So this is a really serious concern. Obviously, COVID has put much more emphasis on remote data collection, but a lot of people are saying, after the end of the pandemic, this is great. We won't go back to doing surveys in the field because it's so much quicker to just use big data. Really concerning, because big data needs to be combined with on the ground data collection, ground truthing, making sure you know who are the vulnerable populations that you want to be working with. Then there's a lot of ethical challenges in the kinds of experimentation, data interpretation that you may be using. So to wrap up, just like to ask them, if big data has such a tremendous potential for evaluation, at the moment, there's a relatively small proportion of evaluators are using big data. I saw a survey a couple of years ago now, so it's a little bit out of date, estimating maybe only 10, 15% of evaluators are using big data. So it's still only used by a relatively small group of evaluators. And it's interesting to think about why does this happen? One of the questions is the accessibility of big data, the cost, obtaining permission, for example, to use phone records, other kinds of government data, the lack of technical expertise of a lot of organizations. So there are a lot of reasons why it can be difficult to access big data, but a critical issue is the ongoing debates between evaluators and data scientists have a very different perspective of what evaluation is about and how you think about data quality. So some of the concerns which evaluators have, which limit the use of big data, different approaches to data quality and bias. A mantra among a lot of big data is using things like social media data. They say all of the data we have is bad, it's of a very poor quality and it's got bias, but tomorrow we'll have new data. And they use this as a joke, but evaluators think, my God, I'm not going to work with data which is of a poor quality. So this is a big issue, just different ways of thinking about data quality. The role of theory, we've already mentioned, the big debate, ongoing debate about correlation versus causality. Many users of big data say we don't need to worry about causality for operational purposes. Correlations are all we need. And the first day, if you become an evaluator, you learn on day one, correlation is not causality. So area of debate. What I call the myth of big numbers, many data scientists say, if you have a large enough data set, this will automatically eliminate bias in some magical way. But if you have bias in a small sample, it will get bigger in a large sample unless you're systematically addressing this. The questions of ground truthing, mixed methods, the need to triangulate, to validate data, which is very often not done with big data. I'm not saying that evaluators are perfect in this respect either, but this is an area of concern. Then just the really big issue we've already mentioned about the importance of direct contact with affected communities and groups, and the concerns about social inclusion. Are certain groups getting marginalized because they don't appear in your big data? Does anybody know that is happening if you're just sitting in your office? So these are some of the concerns which evaluators have about data science. If you talk to data scientists, they have a different set of concerns about evaluators. They say a lot of evaluation methodology is 20 years out of date. Evaluators don't know how to use big data, how to use data analytics, and their methods are just really so out of date that they really need to work more closely with data scientists. So there's issues on both sides which are still limiting the uses of big data. So conclusions, just very, very rapidly, a few of the points, and I apologize, I went quite quickly to cover the ground. Big data will dramatically change how evaluations are designed, conducted, and used. This is going to happen whether you like it or not. Evaluations with the use of big data can become much more powerful management and policy tools because they can become forward-looking. They can give advice using predictive analytics, what is going to happen as the program continues to be implemented, and not just looking backwards and saying what happened in the past. One interesting thing which evaluators have not really come to grips with yet is in the future, evaluation often won't be a separate department, but will be one product of an integrated management information system. Many organizations are setting up these integrated management information systems. So at the moment, if an agency wants to evaluate their program, often they will ask a separate evaluation unit to go and do an evaluation, which might last 3 months, 6 months. In the future, it's quite likely they may go to their data scientists and say, please, could you write us an algorithm to evaluate the performance of our program based on the data which you've already collected. So there's an issue that if evaluators don't really get up to speed with big data, in many cases, evaluation could become somewhat marginalized in the development world. So it's really going to be essential for evaluators to learn about data science. At the moment, most evaluation courses don't include much on big data. So it's going to be a real challenge. It can be an exciting future for evaluators, but they're really going to have to understand and incorporate big data. Otherwise, there are risks that they could, to some extent, become marginalized. I'll stop there, but in the discussion, we might want to talk about how to keep evaluation relevant to development programs. So if we have time, we may come back to that. Oops. So thank you very much for your attention and good luck with your future evaluations. And I look forward to interacting with you during the rest of the webinar today. So thank you.
Thank you very much, Professor Bamberger. It was a very clarifying presentation, and I'm sure everybody has a lot of questions. Before we go to questions, we are going to move to Professor Rodrigo Costas. He defined himself when we were talking before the webinar as a mix of evaluator and data scientist. So maybe he can discuss some of the points you put in the presentation. So please, Rodrigo, now you can do your presentation.
Thank you, Adriana. Thanks a lot. Thanks a lot for let's see, get this. Oops. Can you confirm that you see the screen? Oh, no. Do you see the?
Yes, now we can see.
Okay, thank you. Thanks a lot, Adriana. Thanks a lot for well, the opportunity to come to this space and have the opportunity to discuss about well, this question about big data and evaluation. And particularly, it's great to have my presentation after Michael because basically what he has presented, everything or nearly everything that he has mentioned really applies to what I'm going to say. So the connection is total, and it's great to have this contextualization in the debate. And what I would like to bring to the debate, to the discussion, is more the centrometric perspective. How can we extract data from centrometric databases and try to provide information, context for the evaluations that we typically perform in research evaluation. So this is a brief outline of what I'm going to present. I will explain why I think, or why many of us think that centrometrics have an interesting role for evaluation, and how can it be related to also data science, answering your question, Adriana. Also, I'm going to discuss what are the sources, what are the main databases from where we can get data, and what are the main properties, what are the advantages that we are also finding with them. I will then zoom in a little bit in the specific data elements that we can extract from these data sources, to then move to the actual possibilities, the analytical possibilities, the evaluative possibilities that all these sources and data can provide for research evaluation. And of course, I think it will connect very well with Michael's presentation on what are the challenges and how these challenges can be faced, to in the end summarize a few final thoughts for further discussion. So then, why centrometrics? And to present why I think centrometrics is important, perhaps I need to introduce first what are the typical issues that we have with centrometrics. And in a way, if we would take what is the typical view, what is the typical perception of centrometrics in the context of research evaluation, is because in the past years, in the past few years, the use of centrometrics for research evaluation has been, I would say, quite reductionist, and to some extent also very mechanistic. So evaluators, risk managers, and sometimes also centrometricians, some have argued that indicators like the journal impact factor, like the H index, are ways, indicators that can somehow provide some possibility for research evaluation. So they became really popular. I mean, I'm sure that many of you know these indicators. Of course, we know that this is not the case, that these indicators have a lot of limitations. They don't really measure what is intended to be evaluated. And there has been also quite a reaction from the scientific community, also from the centrometric community, a little bit to highlight, well, the issues, the abuses, the misuses that these indicators, like the journal impact factor and all those indicators used in citations to measure quality and try to rank researchers and universities, somehow pose all the problems that these indicators pose. And here we have the Leiden Manifesto, the DORA Declaration, or the metric type, just to name a few. So somehow, against this context, what I would like to bring today to the discussion is the fact that actually centrometrics is much more than this, and is much more than citations for ranking and for evaluating in a sort of mechanistic way. So what I want to bring today is the idea that centrometrics is data. It has a lot of data, a lot of data elements that can be helpful for our evaluations. They allow for multiple indicators, many different perspectives that can be captured with these indicators. And I would already emphasize that if there is an ambition for centrometrics in evaluation, is to provide more context. So I would start by saying that perhaps centrometrics is not to evaluate per se, but to provide context that can be used for evaluations. And I think that's a very important difference with what sometimes has been discussed, has been attributed to centrometrics. Well, let's now enter to discuss the sources and what type of data we have in centrometrics that can be relevant for evaluation and for research evaluation specifically. I will start by linking this connection between centrometrics and data science, and let's take this definition of data science as methods, algorithms, processes that are aimed at extracting knowledge and insights from structured and unstructured data. And if we take this definition of data science, we can argue that centrometrics it's a powerful approach to extract knowledge about scientific dynamics, about trends, about activities, about interactions, also, of course, about impacts that happen in say in the scientific context, and can be captured via the traces that are recorded in scientific publications. And these scientific publications are indexed, are recorded in global bibliographic scientific databases that somehow allow us to extract indicators, but also to extract perspectives that perhaps are not necessarily evident from a more qualitative point of view. And I would say this is probably the strongest advantage of Centrometrics. Besides, in the context of big data analytics, and aligning with what Michael was saying, I think, everything related with artificial intelligence, with machine learning, natural language processing can be used in the context of Centrometrics, of Centrometric data. So that means that we can perform more advanced citation analysis. We can analyze the citations when they happen in context. We can also study aspects that were not easy to observe in the past, like the mobility flows of researchers. We can perform more advanced clustering of publications, and we can also study how scientific ideas have evolved based on the connections that we find via those citations. Anyway, many of these cases I will illustrate later on with some examples. Let me now really go to the data sources. And perhaps the main message that I would like to send here is that in the past, we were somehow limited by the coverage, by how the available databases were indexing, were identifying the publications that were somehow included in those databases. Well, this context, this situation is changing, and in this study done by some of my colleagues in Leiden, they observe how, for example, the traditional databases like Web of Science, like Scopus, are being outperformed by all the new players that are appearing in the system in terms of databases that capture publications and relationships, citations among those publications. So we have databases like Dimensions, like Crossref, or like Microsoft Academic that clearly are expanding our notion of how many publications can we study and how many citations we can consider in our analysis. So clearly, we are moving to a landscape where we are going to have more and larger databases that can be used in Centrometric work. Moreover, we are also witnessing an increasing in the openness and accessibility of all these databases. So Web of Science and Scopus, so the traditional databases, are commercial products, but more and more we see open databases, like Microsoft Academic, like Google Scholar, like Lens.org, also labs and initiatives by Elsevier or by Dimensions that allow users who somehow would like to do research in Centrometrics to access their databases for free. So it's not only that we have more databases with a larger coverage, it's just also the accessibility to those databases is more open, is more flexible. And in this context, we also have all the local sources, all the databases that would capture specific sets of activity, of production that have to do with countries. I'm thinking, for example, the Cielo initiative, the Sucupira database in Brazil, Redalic, Latindex, and well, many other initiatives and platforms that collect, analyze, and process data about publications from many different parts of the world, many geographical parts of the world. So clearly, we are witnessing a changing landscape regarding Centrometric data sources. And in addition to these, we also have the new data sources, what we could call the alternative data sources, because they bring other perspectives that we didn't have previously with existing Centrometric databases. So I'm thinking here in all the databases that capture social media events, other types of impact, so Almetrics, policy documents, Wikipedia citations, Mendeley readership. All these are new metrics that somehow provide us with new impacts, new interactions that were not previously captured with Centrometric databases. We also have more information about the openness of scientific outputs. Databases like Paywall, like OpenAir, like Core, somehow provide a better access and an open access to publications that are openly available. So that's also an important movement in the field of Centrometrics and science metrics. That somehow the component of open access is more and more captured and more valued in evaluations. And finally, we also have sources that change the focus, and instead of just focusing on the outputs, on the publications, on the books, on the proceedings, they focus on the individuals, on the researchers that produce those activities. And here we have platforms like ORCID, in Brazil, the Curriculo Lattes, that somehow help centrometricians to gather more information, more data, to analyze also the individuals that are producing those outputs. So up to here, there were the data sources. Now let's look at the data. What type of data we can use in centrometric analysis? Well, and I would simply say that any record from nearly any centrometric database is a rich source of traces. Traces of activity, traces of actors, traces of many different things that can inform also many different questions. And with this, I want again to emphasize this idea that centrometrics is much more than just citation analysis. So let's start by, for example, identifying traces about semantics, about topics, about categories, about disciplines. All this is somehow condensed in bibliometric databases. So we can know what are the main keywords, what are the main ideas that were presented in any new scientific publication, any new piece of knowledge that has been published. We also have information about the actors. We have information about the authors, about the journals, about also the affiliations and the funders that these authors have been used. They work for some affiliations, or they have been funded by some funding organizations. So, and all these are actors that have also contributed to the existence of that new knowledge. So we can also obtain indicators about the who has produced this knowledge, who has contributed to some extent to the production of the paper. We have also information about the time and the type of output that has been produced. So if it's an article, if it's a letter, if it's a conference proceeding, if it's a book, all this information is increasingly available in the databases, and increasingly also with more accuracy. And of course, we also have the citation relations, but here I would like to emphasize the idea of citation relations as linkages with other publications. So the linkages that publications establish among themselves. So a citation, so a publication citing another publication is creating a cognitive linkage with that specific publication. So that means that we can connect how ideas, how actors also have been related from a cognitive point of view. I will later illustrate how all this can be used for specific applications, for specific uses. And of course, we also have information about the geographies and how the actors are connected to those geographies. So we know, for example, how what is the affiliation of a given researcher at a given point in time, and for the production of a specific article. We also know sometimes we know when or from where is a specific funder contributed to the production of the knowledge, or even we know where is the publisher of a journal, what is the nationality of a publisher of a journal. And all these allow us to get also a geographical perspective on how knowledge is being produced. Of course, we also have information about other elements. I mean, the language of the articles, and more, as I was mentioning before, the open access of that article. So more and more centrometric databases include this labeling, this indication of whether indicators are, publications are open access or not. And finally, I would say we also have, of course, the indicators of impact that I would propose to treat them better as indicators of interactions. So if we think in citations as an indicator, to me it's an indicator of interaction. It means that someone has interacted with this publication and has considered it relevant for creating a new publication. That's what a citation is actually capturing. And of course, we also have indicators of usage. So how many people have, for example, visualized a given record or the abstract and the title of a scientific paper. And the new indicators, so all these social media interactions that are happening with scientific publications. So we know if a publication has been tweeted, has been mentioned in a blog, has been discussed in a news media item, has been mentioned in a policy document. So all these type of interactions are also increasingly captured by centrometric databases. And on top of this also, we can say that we also count with the full text. So scientific articles, scientific outputs in the end are also texts that have words, have ideas that can be studied with advanced big data analytics. I'm thinking here in topic modeling, the use of natural language processing. For example, more and more we see applications to better contextualize citations, for example, to identify the different typologies of citations, the position of the citations in the text, identifying what is the contextual use of those citations, if it's a citation to support a statement, to contradict the previous statement, and so on. And actually, there are even companies that are starting to produce this indicators, more contextualized indicators of citations, like, for example, Cite.ai. It's a company that, well, characterizes, classifies the citations. So whether citations are supporting, are contrasting, are contradicting, and it's possible to establish the network of citations from this point of view of the type of citation that have been produced or given to a specific publication. So once again, the analytical possibilities really exceed the mechanistic use of citations just for ranking or for producing a journal impact factor. Well, all in all, then I want to reinforce this idea. So Centrometric data is really a rich source of information around scientific dynamics. We can look at relationships, so collaboration, mobility, funding, who has supported a specific research. So the interactions, from cognitive interactions via citations, with interactions on social media, interactions on policy, interactions also on innovation with patent citations, or interactions like readership, like how many people have saved a document to be read in an online reference manager, just to give an example. There's also information about the topics, about the semantics, about the trends, and finally also rich information about the accessibility. If publications are open access, if they have open data, if this open data has been downloaded, has been viewed, and so on. So really, this idea that Centrometrics is a very rich source of information. So let's move then now to the application. So what is possible with all these databases, with all these data elements that we can extract? What can we analyze? And of course, I cannot mention all the possibilities. I mean, it will really take a lot of time, and even I probably don't know all the possibilities because they're really huge. But I will just mention perhaps the less traditional type of Centrometric applications that can have relevance for evaluation. And I call them non-traditional because the traditional typically are the citations and the impact factor. And I want to really reinforce this idea that there are many other applications that are quite often overlooked. So let me start with a first one. It could be simply the networks that we can develop using Centrometrics, so networks of co-authorship, networks of affiliations that can be clustered together because the researchers of those institutions are producing publications together. So the example that we have in the screen is a map of different institutions that are in scientific publications and how they cluster because the authors from those institutions produce publications together. So we can identify, for example, teams of institutions or teams of researchers that produce publications together. We can also go in depth in terms of citation networks. And once again, this idea that citations are more than just impact. So citations are also connections, are linkages between scientific ideas. So then citation analysis allow us to identify the connectedness and the evolution of scientific ideas, scientific concepts. So a tool that, for example, has been developed by some of my colleagues in Leiden, the CitNet Explorer is an open, it's a free tool that anybody can use, would extract from citation networks, where it could be sort of the path of main path of citations in a given field. So would identify the most relevant publications that have contributed to the evolution over time of ideas in a given field. So this is very relevant because, for example, it's a tool that quite a lot supports systematic reviewing in fields. So it can help to identify the more relevant publications in terms of creating citation connections. So how they have connected different ideas during the transition of years. And another way of looking at citation relations is by creating topical classifications. So in general, one would create classifications by, for example, attributing labels, giving specific classifications to journals, to individual publications. But sometimes this type of classifying documents and outputs is quite time-consuming, is sometimes difficult also because it's subjective. And the advantage that we can obtain by using citations is that we can cluster those publications that are connected by citations, either received or given citations. And what we have tested at CWTS is that it's possible to create a quite fine-grained classification of science by identifying those clusters of publications. So the example of the classification that you're seeing in the screen is a classification of more than 4,000 microfields, so individual topics that correspond to groups of publications that are around the same idea, around the same topic. And the reason why they are connected is because they share an important number of citation connections. So it's an alternative to the traditional way of classifying that has its own advantage, of course, but this is a way that can be used, it's a classificatory approach that can be used for very large sets of publications that wouldn't be possible by, let's say, more qualitative approaches. Another possibility, another type of analytic that is possible with Centrometrics. So study the mobility of scientists, the mobility of individual researchers. So if we take bibliographic records from Centrometric databases, and we see that we can connect authors to affiliations. So you can see it in for example, the connection between the numbers of the authors and the specific institution. And we also count with a timestamp, so when a publication existed. So we can see how, for example, in the transition between two publications, between a number of years, we can see how researchers have changed institutions and have changed countries. And if we take this from the data and we aggregate it, for example, at the country level or at the institutional level, it is possible to develop analytics like, for example, seeing how researchers from different continents have moved over time, have moved from one continent to another. Also, we can develop profiles of immigration or migration of researchers. So we can see from which countries are researchers coming to a new country and from where the researchers are going from a given country. I'm giving you the example here of South Africa, just to illustrate how we can study where the researchers are going to and where the researchers are coming from, those that migrate to or from South Africa. And we can also identify networks of countries that are exchanging researchers, that either have researchers that are sent or that are received, and how those countries can be clustered based on this idea of sharing researchers via mobility. And finally, we have somehow the new metrics, the new interactions that I was mentioning before. So we have here, so far everything I have discussed has to do with the scientific world, has to do with Centrometric databases, with authors, with journals, with publications. But the reality is that we have a much larger, much more comprehensive world, where we have Twitter, we have Facebook, we have other platforms where other audiences can interact, can somehow get to say things about science. And at the same time, also scientific actors, universities, researchers can also interact with these audiences via these new platforms, these social media platforms, and also other media like news media or even policy documents. So basically what we have here is an environment of interaction, of exchange. And we are starting to look at these exchanges. And for example, possibilities that we are developing now is how we can compare the science, the map of science, for example, of continents. So this is an example of how we can study the scientific production of Africa and compare it with the scientific production of the European Union. And we can study in which topics the African production has been more discussed on Twitter versus the production from the European Union that has been more discussed on Twitter. And it's very interesting to see how there are different profiles. So while in Africa, the topics that are attracting more attention on Twitter has to do with HIV, with maternal mortality, with tuberculosis or malaria, in the European Union, the research that attracts more attention on Twitter has to do with emotions, with psychological problems, with obesity, with cancer. So we can see how there are different perceptions in the social media realm about the science produced in both continents. But of course, the possibilities go beyond this. So we have the possibility of studying who are these communities, who are these users who are interacting with the science, with the scientific publications, in what we call communities of attention. We can also study the diversity of these non-academic audiences that are interacting with the publications. Michael mentioned it earlier. So we can now produce analysis on the sentiment. What is the attitude of these users with respect to the science? What are they saying in their tweets, in their blogs? What is their perception of that science? So this leads us to applications of how to identify misinformation, how to measure the public understanding of science, if the scientific content has been properly understood, has been properly used, which also connects to issues like the use of fake news around science, when science is disseminated wrongly or trying to mislead these audiences. So we have now approaches and tools that can help us to identify this. And finally, we can also take this as a way for science to extract feedback. So what are these users saying? What are they commenting when they interact with the publications and also with the researchers? So we can get some sort of societal feedback that before we didn't have. And of course, in all these contexts, all this that I've been discussing is full of challenges. So most of the challenges that Michael presented earlier, somehow all of them all apply here. And of course, we also have the more specific type of challenges. So for example, when we talk about Centrometrics, we need to be aware of the coverage issues that, like was mentioned before by Michael. We may be missing important parts of the world. We may be missing groups that are also important and that they need to be studied or analyzed, but they are missed by the Centrometric databases. Well, all the biases, geographical, racial, even age-related biases can be associated to Centrometric databases. We also have issues with quality of metadata, also the dispersion of data sets, so that databases are not necessarily connected. We have also what we could call some sort of social limitations. So it's not only the availability of the data, but also the capacity of those who are interested in using that data, of working with the data. So for me, that relates to the limits in the accessibility and usage of these databases by evaluators. All sorts of technical impediments, like, for example, the need of large computing infrastructure, large computing capacity. So all these are issues that limit the use and the applicability of big data analytics in Centrometrics. And also an important element is the sustainability of these platforms, of these databases. Essentially, who pays for them? So if we want them to be open and accessible to everyone, who is going to sustain these cases? And here we can mention the case of Microsoft Academic. That is one of the largest databases on Centrometrics that are free, are open to everybody. Everybody can do analysis with that database. But they announced this year that at the end of 2021, they will stop the service. And this really raises the question, okay, who should be in charge of sustaining or maintaining these data sources, this data infrastructure? And finally, we can mention something that could be seen as usage limitations. So there is also a need of technical skills, of knowledge of the data, of the limitations of the indicators, of the issues that those databases have, and sometimes this knowledge is not always available. And sometimes we also need to be aware that there is a gap between what needs to be evaluated and what can be measured. So it might be that sometimes what really needs to be evaluated doesn't have the metrics or the data that would capture that phenomenon, that element that wants to be evaluated. And sometimes this is in the Centrometric context, this is overlooked. And somehow I have the feeling that citations were used wrongly in that sense, because somehow it was the idea that what we want to measure is scientific quality. But citations is not necessarily an indication of quality. It's an indication of connectedness, of cognitive relationship, but not necessarily an indicator of quality. Well, let me then just give you a few messages that I think are perhaps the important ones that I would like to convey. The first one is really that Centrometrics are much more than just impact factors or H indexes. There is a whole range of indicators, of data sources that can be used for multiple purposes. Therefore, there is an important richness of data and metadata that can help us to develop network analysis, topic modeling, analysis of context, analysis of interactions, analysis of the actors that are contributing to the production of that knowledge. All this allows for new contexts of evaluation. So evaluation doesn't need to be restricted to just the notion of citations, but we can incorporate perspectives on collaboration, on other types of impacts, on how, for example, workforce has been developed via mobility linkages and so on. Finally, we always need to bear in mind the challenges. So nothing of these analytics, of these data sources, is none of them is free of limitations. And in that sense, I think that qualitative approaches combined with these more quantitative approaches is perhaps the best combination, the best approach. And I will then stop here. So thank you very much, everyone. And yeah, I would love to engage now in the debate with everyone. Thank you very much.
Thank you so much, Professor Rodrigo. It was very interesting also. And I have some questions, but I wait some minutes because we have some questions from the YouTube chat. So I'm trying to have some questions for Professor Michael, and then some questions for Rodrigo, and maybe some questions for both of you. So I'm going to begin here with two questions for Professor Michael. One from Marina Ribeiro is, how can we guarantee ethical approach when using big data in evaluation? It's a quite challenging question. And one from Jessica Sbroglia from the Young Emergent Evaluators Group of the Brazilian Evaluation Network. She's asking that, saying that generally data science is linked to impact assessment using experimental and quasi-experimental methods. And she wants to know how can evaluations with participatory methodologies and qualitative methodologies take advantage of data science to make impact evaluation, especially in contexts like indigenous people, slums, and so on. So maybe we can begin with Professor Michael. I don't know if Rodrigo wants to share some ideas about it. It's okay. Please, Professor Michael.
Well, thank you very much. And thank you to Rodrigo as well for a very interesting presentation. I'll just give a few thoughts on these two very important questions. The ethical questions are really critical. And the first thing is to just be aware that there are ethical issues, because data science and evaluation work in very different fields. And if you're working remotely with data from your office, some of the ethical issues, like, for example, who is being excluded, you may not be aware of those, because you have some data and you dive in and you analyze it. And one of the firstly being aware of the ethical issues. And I think this will come from having a closer cooperation between evaluators and data scientists. So both sides are sharing some of the issues. For example, from the perspective of the data scientists, they will often be concerned that a lot of evaluations are working with very small data sets and make generalizations about to collaborate with the two sides together and come up with, like, evaluators have ethical guidelines. If you're conducting an evaluation, there's ethical guidelines that you're required to follow, and extending those to to big data scientists who are working in some of these fields. So those are just a few very brief points. But I think the main thing is having the interaction. So there's some linkage between data science and what is actually going on in the field. So mixed methods, I think, are really critical. This is just very, very superficial response, and just the question of the concerns about the indigenous populations and people who are completely excluded. This continues to be a challenge of just having a framework for understanding who you do know about and who you don't. So I'll stop there on that question, but it's really critical, and perhaps we can come back to it again. The question of experimental designs and qualitative data is a big issue. I think one of the interesting things with big data is that you have ways of, we mentioned, creating natural experiments, which can include a lot of qualitative issues, that you have a way of collecting a lot of different kinds of data where you can match the project population with other populations using satellite images, using social media. So you can get some idea of the differences, and by creating a natural experiment, you can try and match the two groups and see what the differences are in outcomes. That's just very superficial. And just one final point on some of the exciting new perspectives. I was looking in the United States at a very large program with the National Science Foundation, which had data from something like 250,000 nonprofit organizations. In the States, they have to prepare very detailed tax information on all of their programs. And a study has been done across the whole of the country, comparing all of the information on where NGOs work, what are the services they offer, with some studies from the health departments on a deprivation index of looking at the characteristics of each community in the States in terms of employment, health, access to other services. Bringing these two groups, these two data sets together and working with civil society, it's been possible to identify what are the gaps in service provision across the whole country, and to try and understand the relationship between services, a lot of which are qualitative, and outcomes on reducing the deprivation index. So that's sort of one way. And the final message really is that I think it's critical to use mixed methods where you're combining quantitative data from data science and also from evaluation with qualitative data, bringing the two together using ground truthing. And this can only happen if there's a close relationships being developed between the data scientists and the evaluators. At the moment, they still tend to be in rather different camps. So this is going to be the challenge for the next few years, bringing the two sides together so you can start talking about the possibility of collaborative approaches and mixed methods and so on. So I'm sorry, that's just a very brief response, but lots more things we could say.
Thank you, Professor Michael. Maybe Rodrigo wants to comment, mainly in this issue of combining quantitative and qualitative analysis, because this was your last point in the slide. I don't know if you want to comment some of this.
Well, I think that Michael said it very well. So I agree with him, and my position is the same. I think that the value of all these quantitative approaches is when it's used with the experts in the field, in the evaluation, and what they're doing, and that needs to be done in a qualitative way. So to me, really the value of Centrometrics is to provide that contextual perspective. So in that sense, to me, support for the qualitative more than let's say, a tool per se to take the decisions. So we always insist a lot that all the metrics that we produce are not really valuable if they are not in the hands of experts and people that can use them for more qualitative, contextualized perspectives. So in that sense, I totally agree with Michael.
Okay, thank you, Rodrigo. Just one point about your presentation. You talked about Microsoft Academics, but you didn't talk about Google Scholar, and I think this is quite I don't know, an interesting database. And if you are using, or if you're not using, and maybe you can discuss this. And another issue about your presentation, how to use these new metrics and these new databases regarding some different knowledge fields where publications in journals are not the main vehicle of dissemination of results. So you have some clue about it?
Yeah. So let me then start with the Google Scholar question. So the problem with Google Scholar, to be considered as big data and with big data analytical power, is that it's a free tool that indeed contains a lot of data, but is not accessible. So it's a source that doesn't have an API, that doesn't have any way of extracting the data in a relatively large scale capacity. So that means that for, let's say, big data analytics is not useful. It is a very interesting tool to, for example, explore at the local level. I mean, groups of publications, groups of authors, their citation relations, and the production of scientific publications. But it lacks this large scale analytics. Microsoft Academic could be seen as, okay, it was, or it still is, the alternative to Google Scholar, in the sense that it collects data from the web about scientific publications, establishing all the relationships in terms of citations, the authors, and classifications. But I mean, as I mentioned, it has this challenge now that it will disappear. And somehow this is triggering a debate in the community on how can we come up with sources like Google Scholar or Microsoft Academic that are community owned, that are open for everyone, and that can help to answer all the Centrometric questions that Google Scholar or Microsoft Academic can currently allow to answer. On the coverage of fields of science, so that's a long-standing issue. I'm thinking particularly about books. That is the typical type of the traditional type of output that has been excluded from most databases. There are initiatives to try to index books to include them. I think they're not yet like with the size and the optimum usefulness that we would like. I'm thinking, for example, Google Books could be a nice alternative, but once again lacks this large-scale analytical power. And it's one of the challenges. But the trend really is to increase coverage. So what we have seen with Microsoft Academic, we're seeing also with Google Scholar, is that databases are growing in terms of what they include. So I mean, I think it's reasonable to argue that in the future we're going to have databases that will have much larger coverage of all sorts of outputs. Perhaps the interesting challenge, because it brings a conceptual challenge, is what will happen with those outputs that are not the traditional scientific outputs. So thinking software, thinking in data sets, thinking even social media outputs like blogs, like news media items produced by the researchers, and all sorts of type of digital objects that are being produced by the scientific community. That is an important challenge, because it may not be seen by, let's say, the Centrometric databases, the Centrometric data providers, as outputs that need to be indexed. And an approach that we are using to try to identify them is to use institutional repositories, or, for example, ORCID. or for example, the curricular lattice in Brazil, where scientists have somehow the freedom to indicate other types of outputs that they are producing. And somehow this could be markers that the community is also transforming the way they produce and they communicate with others. So then my suggestion would be to always keep an eye on these more flexible tools, because they are the ones that will show us what is changing in the scientific community in terms of what they are producing that perhaps is not yet indexed.
Okay, thank you, Rodrigo, very clarifying. We have a question here from Susanna Morrison from AUNAP. I think she was oriented to Rodrigo, but I think both of you can answer if you have some examples. She's wondering if you have some examples of artificial intelligence textual analysis applied to databases of evaluation reports. She's saying that they have a database of over 20,000 humanitarian resources, including evaluations, and she wants to know if both of you have any experience with that.
Rodrigo?
I mean, I don't have examples of evaluation in the sense of general evaluation. So I know that there are colleagues that are starting to explore peer review. So with the emergence of open peer review, in which the evaluation of scientific articles are published together with the articles. So there are colleagues that are starting to look at those texts and how the evaluation of the articles have happened. So. But specifically looking at reports of evaluation, I don't have any experience.
Okay, could I just give a couple of examples? One is that a lot of organizations, including the World Bank, the UNDP Evaluation Office, and many other organizations, are starting to use artificial intelligence for reviewing all of their PDF files of evaluation reports. So a lot of organizations like the World Bank have produced thousands of evaluation reports, and previously it was very difficult to try and do any systematic overview of the findings. So now they're beginning to use AI to be able to filter through literally millions of pages of the evaluation reports and to look at the patterns and some of the lessons learned. So this is a field which is just beginning to develop, but it's very important because so many organizations until recently, most of their data was in the form of physical reports, which might be online, but they weren't really digitized. And so nobody really knew what to do with it. So it's now becoming possible to track these huge amounts of data, which is really critical because you can now learn from your past experience with what didn't work with evaluation, which couldn't be done before. So that's sort of one area. The other where there's a great potential for AI, which at the moment Rodrigo would know better than I do how much this is starting to be used, which is what evaluators call a systematic review, where you identify all of the evaluations which are being conducted anywhere on a particular topic, like, for example, the impacts of microcredit on women's economic and political status in the household or the community, where you identify all of the evaluations which have been done in any of the documents you have access to, and then you filter for some criteria of quality, and then you start looking at the patterns, and you actually use statistical analysis to look at how many reports there were of a particular kind of outcome and how statistically significant this is. So this is a very exciting field. One of the issues at the moment is the criteria which you use for assessing what are valid reports. And until a few years back, they were influenced by the medical community, where you only accepted reports which were using randomized control trials. So this was being used for a number of systematic reviews as a filter. and you only include evaluations which were using RCTs or strong quasi-experimental designs, which is a useful screening criteria in some areas. But for example, in looking at gender impacts, a number of these systematic reviews have excluded 90 or 95% of all of what were considered good evaluations, because you rarely use RCTs in gender evaluation. If you're looking at the impacts of having access to small business loans by women, you don't tend to be using large-scale randomization. It's much more detailed qualitative tracking through the changes over a period of years. And so you can come up with a report which is rigorous scientifically and which is completely misleading, because you could have rejected all of the what are considered very good evaluations, but which were more qualitative. So this is a very exciting, it's a very valuable field for evaluation, but there are still the challenges of what are appropriate screening criteria to use to make sure that you're ensuring levels of methodological rigor, but also you're accepting some of the things that I think Rodrigo was talking about a little bit. There are different sort of kinds of research in different fields, and so you have to be able to look at what are considered valid methodological standards in a particular field. So that's an area which is being used quite widely, but I think there's a lot of very exciting applications of AI to deepen and broaden this, using all of the kind of things that Rodrigo was talking about.
Thank you, Professor Bamberger. It's interesting because there's also a database of policy evaluation from Science and Innovation Policy Evaluation, which is hosted from Fraunhofer Institute. Mm-hmm. And maybe this is an interesting path to analyze this database. Now I'm going to call Sergio, which is also with here in Zoom. He has a question. Please, Sergio.
Thank you, Adriana. Thank you, Professor Bamberger, Professor Costas, for your excellent presentations. Very interesting. I was wondering here, what are it's for you both, the question. I know this is not an objective question, but I will try. What are the main challenges and maybe bottlenecks that we have to overcome in the near future to get more and more evaluations performed using data-driven evaluations? I understand that we are not going to have, maybe we are going to have some only data-driven evaluations. We already have. We tried to do one or two only data-driven evaluations, but the question is, the more you have data and data sources, the more you have to combine different variables from different natures, the more difficult it is to analyze and to have a mathematical, econometric, or a statistic way to analyze this. So I suppose this is one of the challenges we have ahead. I mean, the way the innovation in terms of the analytical tools, but in terms of what are we going to face in the near future in terms of challenges to make data-driven evaluations more regular, a more common thing?
Rodrigo, do you want to begin?
Okay, I can I can begin. So I understand, Sergio, that your question is somehow what are the, I'm not sure if it's about the issues or about the possibilities, because you're kind of touching both. So what are the issues of using data-driven evaluations, and if data-driven evaluations will be the norm in the future? I mean, I believe that the issues have been discussed by Michael. I also raised a few of those that apply to Centrometric data. I mean, it's full of biases, it's full of limitations. So we don't have complete data, we don't have perfect data. And so far we don't have, and probably we will never have perfect data. We always need that human interaction, that will somehow contextualize, would identify the gaps and the problems. So what I would say the main bottleneck, so to say, is that in the moment that we want to assess something only data driven, we will inherit all the limitations of the data, and the data will always have issues. Then we have the question of the if there will be more data driven, and in that sense, I do think there will be more data driven, because it's not only an opportunity. It's not only that we have all this data and we can learn more from it. It's also that it's necessary for the evaluation. So for me, data, I mean, and databases also bring unknown elements that were not previously considered. I will give the example of the metrics. So what you can have, I mean, you can have a context where you're using citations, publications, and somehow making your decisions based only on that information, and even perhaps as an evaluator based on your own criteria, your own perception of things. And I could present you with perhaps something that is happening on Twitter, that is happening in news media, that could bring you another perspective. Say, okay, maybe I can change my evaluation now because of this additional data. And in that sense, I think data will be helpful for these purposes, to somehow expand our perspectives, to challenge also the current understanding of things, and bring in new perspectives that were not available.
Can I just add a quick point? I don't know how much time we have left. Okay, well.
Yes, sure, Professor Michael.
Okay. I will talk with the biases of an evaluator, so I'll be talking from that perspective. One of the challenges but exciting opportunities is, at the moment, many data scientists don't have an evaluative framework. They're not normally thinking about evaluation questions. They're looking at different kinds of questions, a lot of which came from the market research context of some of these technologies. But for example, they don't tend to think about causality, often don't have a theoretical framework for thinking what kind of data do you need to collect. So I think one of the big challenges is going to be the closer linkages between evaluators who have experience of how you frame evaluation questions and the data scientists who can generate both the kinds of data and the analytical frameworks for the analysis. So I think that's going to be an essential condition for bringing big data into evaluation, a closer links between the two fields. And I mentioned briefly some of the challenges of doing this from the I go to a lot of conferences with data scientists and evaluators, and a lot of the data scientists at the moment are quite disparaging of evaluators. They look upon evaluation methods as being very out of date, and their goal is, we'd like to go and help our ignorant evaluation brothers and sisters how to improve the work they do. It's very unusual in my experience to find big data scientists saying, boy, there's so much we could learn from evaluation. We really need to think about causality. We really need to think about causal modeling. So at the moment, a lot of the data scientists think they have things to share with these poor evaluators, but it's quite unusual to see them saying that there's so many things we need to learn from evaluators. So building up this kind of framework where both sides realize they can learn from each other. And then from the evaluator side, as we mentioned, there's a number of reservations about this, a bit suspicious about their big data methods. A bit nervous it's going to take over evaluation. A lot of organizations have concerns about the competition for resources. So I think bridge building up this consensus, getting a lot of funding agencies to think about funding pilot projects where they bring together data scientists and evaluators specifically to assess the value added of a collaborative approach. So I think that the bridge building using mixed methods is going to be the way to go. There's tremendous potential for collaboration, and I focused on this area of the using systems analysis for providing a broader framework for analyzing complex programs. I think that's one of the very exciting areas where you can see you really need to have the collaboration between the two. So I think that's basically building up this framework within universities, within government agencies of bringing the two sides together, where both sides realize what they can benefit from the other. So that's an exciting opportunity and a challenge at the moment. And I'd just like to say the final point, I've interviewed a lot of big agencies, and you still find that often the data center is quite separate from the evaluation office. I was talking one big donor agency with their data center and all of the things they were doing for improving the performance of their programs on the ground. And I asked them, well, what kind of collaboration do you have with your evaluation office? And they said, that's something we should really think about in the future. They didn't even see it was one of the things as a data center within a donor agency they should even be thinking about. So there's still quite a long way to go, but an exciting future, I think, for everybody.
Okay,
thank you for both.
Sergio has another point.
Yes, I have many, but I will not have much time left. So thank you for the answers and the comments.
Okay, so I would like to say we are very much pleased with your participation here, Professor Michael and Professor Rodrigo. It was really fun, really nice to have you here. And we have more questions, but we are out of time. So unfortunately, we have to end now. And before going, I would like to announce we have two scheduled events from GEOPI. And the first is at June 25 with Estelvia Matos, who is the co-editor-in-chief of Technovation. She will discuss trends and themes for publishing in the journal. And some challenges for developing countries in this sense. And we have also in 2nd of July, another webinar that we are going to continue in this theme of evaluation. We are going to discuss evaluation in COVID-19 context. And then we will have Andrea Skakauskas from Plan Eval, and also Fábio Bezerra and Faye Manheshi from UNICEF, Mozambique. And we will have the mediation of Ana Maria Carneiro from NEP Unicamp. So we invite all of you to be with us in the next events. They will happen in our YouTube channel, GEOPI's YouTube channel. So please, you can find more information in our channel. You can find more information in our website and also in our Facebook. And thank you, everyone. I don't know if Professor Michael, Professor Rodrigo wants to say something else. Goodbye for everybody. Thank you a lot.
Muito obrigado.
Obrigado, Rodrigo.
Muito obrigado e boa sorte para a gente com as evaluações futuras.
Muito obrigado, professor. Até logo.
Até logo.
Obrigado. Thank you all. Thank you.